Hello, welcome to the data channel and you're watching Python Bootcamp for Data Professional. And as part of topic 22, so we'll be explaining data sets like lists, sets, dictionaries, and tuple. So here in this particular video, we'll be discussing about performance comparison and analysis between all of these data, like data structures or data types in Python. So in the previous video, we have discussed this comparison of these data structures. Theoretically, we have seen the comparison, when they can be used, how they can be used, in which scenario, which list or set or dictionary or tuple, which data structure to be used. So that we have already seen in the previous video, and in this particular video we will concentrate on understanding the performance comparison and the analysis between these. So when we say that whenever we use a particular data set or data structure, what is the performance implication, or the what is the memory analysis, how does it occupy the memory internally. So if you're interested to know that, so know these details, so then definitely you need to watch this video completely till the end. So before that, if you are new to this channel, we would recommend you to please subscribe and also press bell button for instant notifications. So let's get started. So this video is more of a theoretical. So we will be just doing a comparison with certain examples. So as you can see, before that, we need to understand why understanding the performance comparison is crucial. So you might think, okay, I have already having a data structure. I understand data structure, what is list, what is dictionary, what is tuple, and then set. So you know how to use it in a multiple different cases. So then there might be question coming up, why do we really need this video which is explaining about the performance comparison, and why it is critical or crucial as a developer, why we need to understand this, right? See, we need to understanding performance comparison is very crucial because it enables as a developer, right, to select the most efficient data structure for a particular use case that you're working on, and ensuring optimal execution speed. Because today you might be working in small data set, but in real time, when the data might grow, or you are working in a real time projects where the data is in millions of billions of rows are there and records are there. So in that case, we need to ensure there is an optimal execution and it is more sustainable solution. And you need to smartly use the resources, because you might be using Hadoop on-premise cluster, you might be using some virtual machines where you are running, or you might be using a cloud, Databricks or Snowflake, or you might be using some like on-prem machine as well. But end of the day, whatever resource you use, there is a cost associated with that, right? You need to understand. So for everything there is a cost. So nothing, no resource comes as a free, or it is having an unlimited resource or unlimited memory or capacity, right? And whatever you are consuming for running a particular code, there is a cost associated behind that. Okay. And so that is the reason it is makes it important to like efficiently data structures can significantly improve the performance of the whatever code or algorithm or the application that you're building. And particularly in case of scenarios involving large data set and time sensitive operations, maybe like transactions related data, so those are very time sensitive, right? And this knowledge helps in writing a scalable and maintainable code, and it is more sustainable over the long period, right? And that will lead to a better overall software performance, and it gives a better user experience, because there will be no lag or no delay when it is operationalized in the production scenarios. So so this is why we need to understand the performance comparison between these data types, and smartly use or smartly choose which data structure or data type to use. Okay. So now let us see the operations and its time complexities. So when we say operations, we have lists, right? We have sets, we have dictionaries, we have tuples. Okay, but let us take first as a list as a example here. So when you see list as an example, so here we are creating a list first, right? So then once we create a list, so we are appending. Okay, so these are all the operations: append, insert, remove. Okay, and membership test. So these are most commonly used operations. There are other operations as well, like pop and all those operations for list, but we are not considering them. We want to understand which are the most frequently used operations here, and what is the time complexity. So if you don't know about time complexity, so just quickly, it is operating, it actually the concept of a operating system, or wherever you want to do a analysis on the algorithms, you want to do like a time complexity on an algorithm or a procedure. Suppose you write a code, right? How much time it takes, and as a like as a data set changes, or you are doing any performance, any operations on that data set, how much time that particular code takes to execute. So that is, there is a holistic way of measuring that. So that is what we call as a time complexity. Say for example, to take a simple example here, right? So we are using a append operation. So we say it is taking big O of 1. So what is big O of 1 is, big O is a notation to denote the time complexity, and one is, it is one means it is taking 1 second, say for example. Okay, it is just, you can convert it to any measure, so it might be 1 second, 1 minute, 1 hour, whatever. But to keep it simple, we will take it, it is taking 1 minute. Suppose there are, like here, 1 million records. Okay, so even though there are 1 million records, it take only 1 second. Okay, so if it is big O of n, that means, so suppose if I want to insert a record at a particular element, okay, then I need to shift the existing record. So suppose I want to insert 1.5 in between 1 and 2 here. Okay, so in this case, what happens is, I need to shift all the, if there are 1 million rows, all the 1 million rows has to be shifted to the right side, because it is a, as you know, list is having a, it is based on the indexes, right? So all the elements, and it is ordered, so all the elements, to maintain that order, all the elements have to be shifted. So that is why it is big O of n. That means, if there are 1 million rows, okay, if there are 1 million records in the list, or elements in the list, it will take 1 million seconds. Okay, so it is again just a speculation, we are taking second as a unit here, you can take microsecond also. So that is just a notation. So how many elements are there, that many number of units that it takes. Okay, and to remove also, it takes big O of n. Okay, so need to first like once the element is removed, again we need to shift back the all the records to the particular, we need to arrange that back. Okay, and for doing a membership test also, there is a big O of n, right? Why means, because it has to traverse through all the list one by one, right? So the three, if I'm giving three here, so it has to start from zero index, and it has to start check 1, 2, 3, 4, 5, 6, like till 1 million records it has to go on searching. How many times it has searched? It has searched n number of times. That is why it is big O of n. So if you understand this concept that we discussed now, so whatever we'll be discussing in next, it will be very similar. So in case of set also it is same, similar actually, if you see, right? If you want to add, it is big O of 1. See here it is different, right? When you are inserting, it is big O of n, but in set it is big O of 1. So it is, set is more what you say, in terms of performance, in terms of especially when you have large data set, you're performing any kind of the such operation of like adding, removing, and doing membership test. So this is very important in set when it comes to set. So when you want to do a membership test, so it is obviously the set is a first preference, because as you can see, it is taking here, if it is taking say, if there are like 100 records, if it is taking 100 milliseconds, here it will take 1 millisecond. That is the difference between list and set. Okay, so the with respect to performance here, right? And similarly, you can see remove, everything is big of 1 here, because there is no concept of index, or there is no concept of it is not ordered, right? So you can keep it in any order. It will just go and put this record at the end, right? So when you it will just put it here, but here it should find the position, go there, put the record, and then do a rearrangement of the all the records. So that's why it is big of n complexity. And similarly, if you see dictionary, so dictionary is also everywhere. It is big of 1, 1, 1, and here also it is a faster membership test. But here it is based on key. But in set it is always the values. So that is the difference between set and dictionary. But here also it is all big O of 1. Why? Because it is always indexed by the name or the indexed by the key, for example, right? So it directly knows which key it is going to modify. It will directly go to that key. So it will go to the C, okay, and it will just add one more element. It will just add here. So if I want to add one more, it will just go on adding it, right? So it doesn't need to shift anything like intermediately or put anything in between. Okay. So tuples also, as you can see, index is big of 1. Like when you are doing accessing an element, it is big of 1. But when you do a membership test, it is again costlier operation here when you are having tuples because it is having lot of records. I mean, if it is having lot of records, it will take a lot of time because it has to traverse through all the records. See, like you can just start thinking the multiple scenarios, right? So if you have 1 million rows and if you want to performance if you want to do a membership test, so then you can think what is best, whether list is better, list is best or set is best in your in that case. Obviously set is best because it is taking like 1 millisecond instead of 100 milliseconds. So and if there is a key value pair scenario, then definitely you can choose a dictionary. There is no other option apart from dictionary. If there is a key value pair, you have to obviously go with that. And tuples, we need to again use it very sensibly. So tuples should not be used where there are million number of records, again because it is like if you want to do a membership test or any kind of accessing the element, so it is again costlier, okay, when compared to set. So that is why tuples should be used in a scenario where there is very less number of records and it is used for just a configurations, maybe 100 of 100 200 elements are there. Even in that case you can choose tuples. Okay, so these are just examples, right? You can think of. Okay, so now let us move for the next one where you we understand the detailed performance analysis and with the memory usage also we will see here. So first is list. So list, what we are saying is accessing an element by index is big O of 1. So that is what we have seen. And however, inserting or deleting elements in the middle is big O of 1 because there is a elements need to be shifted. So that we have already explained or that we have already seen. Okay, and coming to the memory part of it, right? So list have some memory overhead here due to their dynamic nature and their need to store pointers to the each element. So that is why, right? So when we have a list, okay, so for each element 0, 1, 2, 3, 4, whatever elements we have, so for each element in the list, there will be a pointers created. This is a zero index, this is a first index, this is a second index. Everywhere there is an index. So that is because it is having an index. So there is definitely a additional memory overhead, and due to their dynamic nature and need to store a lot of pointers for the elements, there is additional overhead here. Okay, and if you consider set, so set is it's adding, removing, and checking for membership is always big O of 1 on average due to its use of hash table. So internally set uses hash table. It uses a mechanism something called as hashing. So you can just Google it and see what is hashing. So hashing is one of the technique to index and index it, and it will help in faster retrieval or storage of the data so that it can be retrieved faster using hash keys. So because set is uses this one hashing internally to the for the implementation, it is a bit faster and it is just a big O of 1 complexity whether you do add, remove, or checking the membership. Okay, and set is having higher memory overhead again compared to list because of hashing mechanism. So you might think, okay, set is more powerful than list, but actually when you go to the implementation of set, because it is using hashing mechanism internally, so it is less performance intensive. I mean, it is more it is having a higher memory overhead, okay, compared to the list. Okay, so list is better in terms of memory when you compare that with a set because of this hashing, whatever internal implementation and all those things. But as a user, as a developer, if you see, it might look simple from the complexity perspective. Okay, but from the purely from the memory, how it is consuming the memory, right? Because it has to do lot of it has to keep a lot of metadata inside. So that is why if you are looking for the memory like memory what you say the saving the memory perspective, so then you need to look for set. But if you are looking for more performance intensive and you don't care about memory, so then you can even choose list. Okay, but again it depends on the scenario and the data set what you are using, how many times you are using in a day, right? Frequency of it. So everything matters. Sometimes it will be trial and error also. And next is a dictionary. So dictionary is like accessing, adding, deleting element is anyway again it is very similar to set. Okay, but also it uses a hash table similarly like set. Okay, and dictionary is having the highest memory over it among the data structures that we have seen. Okay, so if you see, when you purely see from the performance or the sorry from the memory perspective, dictionary is a least option. This is a last option. This is a priority 4 option. So then we can choose like a set. Okay, so then we can choose list. Okay, and the finally is a tuples. We will see that. But if you see the priority, if you see the which is using the memory in its best is list, and then set and dictionary, and last is having the dictionary is having the highest memory over it, because this is having a key value pair, and it is already having a hashing, and on top of that it has to maintain the key value pair. You can imagine in the memory it has to store keys, it has to store values, and again on top of keys it has to build indexes, perform hashing. So lot of metadata will be stored inside in the memory, right? So that is why dictionary is a least or worst in case of memory management. So finally we have tuples. So accessing elements by index, we have seen it is always big O of 1, but since tuples are immutable, you cannot modify them. So that makes it more powerful in terms of memory, right? So tuples are more efficient, memory efficient than list because they are immutable and fixed in size. So here, because we are not performing any operations, tuple are once you create it, it is all like it is there, and there is always big O of 1 complexity, and if there is like always static values, nothing is changing, nothing is getting deleted, nothing is getting added, right? And it is immutable, fixed in size, so that makes it more more memory efficient, right? In terms of because it doesn't have any metadata, it doesn't need to store any information about how the data is stored, why the data is stored in this way, like all the indexing, nothing is need to be done here in this case. Okay, see tuples again. So as you can see here, so this is again if there is a scenario where you want to choose between list and tuple, okay, you can still choose tuples where you think the values never changes, right? In that case you will have better memory management here in this case. So with purely from the performance point if you see, okay, it again depends whether you can choose whether if you have a key value pair you need to go with a dictionary, or if you have a uniqueness and other things you need to choose between list and set. But again, so if there is nothing specific, so then you can still go with the set because set is more powerful and it is always big O of 1 compared to list. But again, if there is a scenario, more specific scenario where you don't have a scenario where you don't want to change any value in the list or in the element, so then you can choose tuple. So tuple is last option, but it is a more better option in terms of memory efficiency. So hope this explanation was useful, right? And it will help you in understanding a couple of things when you are implementing in real-time projects, right? And this is very key in understanding these concepts in detail, so that as a developer you can build a sustainable code which will run over the time, and it doesn't impact because of the increase in the volume of the data, or increase in the sudden increase spike in the data or something in those scenarios, right? We need to analyze all those things and come up with the best data structure to use. So finally, um, so it again, we will take one practical example to compare the performance of these data structures, and we will measure the time in real time. So this in the previous slides we have seen how much time it was take, like we were just seeing big O of 1, big O of n, right? So we will practically see that how exactly it looks like when you try to execute the code. So we will jump into this demo and understand this. So first we will start with list, right? So we have imported a time library here because we want to measure the time. And in the first here, in the first in this line, what we are doing is we are taking the, I think, around 1 million rows, right? So yeah, 1 million rows we are taking and we are assigning it to like one list called list data. And then we start the time. We will start the timer, and we will try to append a particular element to this list, right? And when we append, it will go and add at the end, right? And then we will measure the time complexity, right? If you execute this, so as you can see, it has taken 0.01 seconds. So let's execute one more time. Yeah, it is taking consistently 0.01 or 0 point around that 0.01 or whatever, right? So like that is a big O of 1. That means it is taking one. This is considered as a 1. So you need to consider this as a 1. So wherever there is a case of big O of n, right? So in that case, it will consider it as a multiplied by that many number of records, right? So it might not be exactly mathematically it will be exactly true, but it will be around that, what we can say. Suppose if I want to, now in this case what I'm trying to do is like I'm trying to remove. So let me try to remove certain records here. So here I'm trying to remove this whatever we have inserted, right? Not it, it is a different element we are trying to remove here. And list removal time, we will measure what is the list removal time here. So list removal time is also almost same. Okay, so that means it is big of it is taking big of n actually in both the cases. Okay, and let's take a set as an example. So even though it is n, it is too fast because it depends on your memory cluster memory and all those details, right? So it depends on all those factors. So it doesn't mean that big O of n means it should be very high number, okay, or it should be a million in terms of millions, right? So again, we will try to execute set example here. So we are doing the same thing for set here. We'll try to execute this. So as you can see, set is very quick. So it has taken how much time? It has taken 0.000. It's very negligible. So it is like here, if it is taking 0.00009, so it is nothing but it is big O of 1. And here we are calculating as big O of n, right? So 1, sorry. So big O of 1, even though it is considering like, so this 0.00 whatever, it's almost zero, what we can say, but for the calculation purpose we can consider this. And we have a million records here, right? Into 1 million. So this will approximately lead to this number, whatever we were thinking. So which is actually what? Big O of n. So that's the difference here, okay? And even you can try removal operation in the list. So in the set, so set is always what? Big O of 1. Set is always big O of 1, right? So again we'll try to remove this. See, removal is almost 0.09, sorry, 0.0. Yeah, it's already removed, right? So that is why we are not able to remove. But yeah, so let's try to remove one more record here, random record. See, it's almost zero, what we can say, negligible, right? And next, let's take a example of dictionary. Okay, so dictionary is again it's big O of 1, right? So it should not take it should not take time like this 0.02 or whatever. It should be very negligible, right? So as you can see, it is in terms of zero point 0.0 or 0.001, something like that. And again, it is a similar calculation what we have seen. So this is what it is, the calculation of the comparison between 1 and n. So 1, it is a magnitude. Basically, you need to see as a magnitude. If it is 1 magnitude here, okay, in terms of dictionary and set, in terms of list, it is n magnitude. That means how many elements. As you can see, if there are more elements we are adding, so it will increase actually. So now we have three digit. So this is set, right? So let me go to the. So set will never change. So even though if you add two more zeros also here, it will not change. It will almost be zero point 0.0 whatever. So here, if you start if you increase the number of records, it will slightly affect the list append time here. So if it is 1 billion or 10 billion or 20 billion or 100 billion, so it must increase the time that it is taking. However, in terms of big O of one scenario, okay, whatever the number of rows or elements that we have in the particular set or in the dictionary, right? So it doesn't matter how many rows are there. So it will always take big O of 1. That means it is almost equivalent to, it will not increase over the time or as the data increases. So that is why it is big O of 1. So, and finally we will see tuple scenario, right? Tuple also is very similar to, it's like most of the cases are like big O of 1 here in the, even in this case. Yeah, as you can see, it's almost zero point 0.0, zero point 0, and even though if you increase the number of rows, it is, since it is always big of 1, so it doesn't matter it is, if it is having 10 rows or if it is having, so it doesn't matter. So suppose if I give 10 rows also, it is almost same. Okay, so I'm deleting here the number, the rows. Let me comment, delete maybe 5 from this list. Okay, you can see here, right? It's almost 0.00. In that case, it's very negligible when it is calculating. So it is always around 0, big O of 1, even in this case. So when you are working on time complexity, make sure you understand that it is conceptually, because it will not be exact numbers, but only the considerable thing you can note is as the number of rows grows, as the number of element grows, so the time complexity, if it is increasing or the time it is taking more time, so then it will be something around big O of 1 n. Okay, so if it is, you are, if you are increasing the number of elements and it is not significantly changing the time, so then it is always big O of 1. So that is what we need to understand when it comes to time complexity, right? And like if you see summarizing this, right, lists are good for ordered collection and frequent appending, but can be inefficient for frequent insertions and deletions in the middle. It is costlier. And set is ideal for collection of unique elements and faster membership tests. And dictionaries is best whenever you have a key value pair and access insert and deletion by keys. Okay, because it is hash indexed. Tuples are suitable for fixed collection of items and where immutability is required. So, and also keep this slides in mind, right? Like the previous slide we have discussed here. So this, so these all the points are very important here. So wherever we discussed, right, the memory aspect of it and other aspects of it. So why dictionaries are more memory intensive, and why tuples are not so memory intensive, and you can use tuples if you want to save the memory in certain cases. Compared to list, also tuples are better. Okay, and this is a priority 1 2 3 4, tuple, list, set, and dictionary. So dictionary is a least choice and tuple is a best choice when you're looking for the memory option. See, it is always the trade-off. You cannot just think of memory, because there might be scenario where you cannot use tuples. You have to use dictionary or you have to use list. So in that case, you don't have any like choice. But so memory usage, you need to think when there is a choice, right? So when you, as a developer, you have a choice to choose between list and tuple. So then you need to choose tuple, because you have a choice and you can save the memory. So that is what the best developer will do. Okay. So hope this all the concept of like it was more technical and it was more theoretical, but also we have seen some practical elements to support that. So hope this will be useful in the real-time projects where you're working. And if it is useful, we would recommend you to please subscribe and also share it with your friends and colleagues. Thanks for watching.